Hello. So I want to go over this question with you on a spring that's attached to a ceiling and then it's pulled down a certain amount and um, will reduce every time it comes down, right? So its initial energy will be the most and it'll diminish over time. So what we want is for our maximum, right? So here's an example of what it would look like. Here at 0, we would see that it's pulled all the way down, and then it's pulled down from the ceiling, and then when we let it go, it'll slowly diminish to a little less than what it was before. As you can see, over time, it'll slowly reduce itself from the distance it is as it's oscillating back and forth there. So the form it's going to be used is what's called the diminished amplitude, and this is an exponential decrease because we can see that it's decreasing by 1% here. So if we focus on that part of it, what we know is that our A is going to be the 5 centimeters that it was originally pulled down, and then since it's decreasing by 8%, that means it'll have 92% left over afterwards, making this like our exponential decrease off of it. Now, in order to make it oscillate, we need to ask ourselves a couple of questions. One would be, which trigonometric function would be the best way to represent this? Since it's pulled down, it's at its maximum distance right in the beginning, which makes cosine ideal for it. And then for me, because I'm pulling it downward, I'm going to call that a negative, or I'm going to call that the positive amount that came from. So it's going to start up on the top and then get close, bounce back, and so on. So in order to find its period, I know that what I need here is I need to know what this value b is going to be. But I'm not going to be shifting it horizontally, nor am I going to be shifting it vertically. It's going to start that same distance on there. So if we were to look at how b relates to these trigonometric functions, what we do is we have our regular period, which is 2 pi, and then the amount that it takes to cycle through. In this case, it oscillates 19 times each second, so I'm going to call that 1/19 there. I could do the math on this, and what this will do is it'll cause it to be 2 pi divided by 1/19 or times 19 there, which means what I need to have here is 38 pi right here for b. So if I place that in there and then replace it with with a t, I can see that what I end up with, let me change it to an x because Desmos isn't recognizing that variable right now. What I can see here is that this thing is going to start 5 centimeters away, and then it's going to decrease to 92% of that every time it cycles through. So you can picture it like it pulled away, then it came back down, then it came back up, and so on with it. So in order to put all these things together, I need to have the exponential piece of it, how much it's decreasing by, which it's better for me to think of it as, well, how much is remaining. So if it decreases by 8%, I have 92% every second. And then that period is going to be the hardest part, trying to picture what that's going to end up being. But if you always remember the period is going to be related by being 2 pi over b, then we know that b is going to be equal to the 2 pi over its period there. I hope this was helpful. I hope you're well. And by all means, if there are any other questions, let me know.